So the period is the distance between the asymptotes, because if you notice about our tangent graph, every asymptote repeats itself. So the period is how long does it take to start repeating itself? The distance between the asymptotes, which is different than sine and cosine. For tangent, it's going to be just pi over b, not 2 pi over b. So that's an important difference. Sam probably should try to stay awake today. Maybe a pencil, some paper out would be a good place to start. We say that amplitude is undefined for tangent. That doesn't mean there's never going to be an a value. We talked about yesterday at the very end of class. If there's a number in front, it's going to stretch that curve out. But we don't say that it's an amplitude, because if you look back at your definition for amplitude, amplitude is defined as the distance, half the distance between the highest point and the lowest point on your sine and cosine graph. Does tangent have a highest point and a lowest point? No, it keeps going forever. So we don't say that it has an amplitude, but that a value in front is still going to stretch it. B is still going to affect the period. C is still going to be a phase shift. D is still going to be a vertical shift. And just like with sine and cosine, you are not going to have to graph a phase shift ever. So I might throw something in there with the phase shift, but you would never have to graph it. What you need to know is how to find those asymptotes, and that's what this other thing is. This is the one big writing thing today. And then the rest of it's just graphing. I'm missing 3 calculators. I was missing 4 calculators, but then someone, Valerie, found my calculator on a water fountain. And so she brought it to me. So now I'm missing 3, or maybe two calculators. So if you just happen to have one, just check your locker. They cost a lot of money when they start missing. Like, you're just missing one, you're like, oh, that's only like $12, $13. But then when you're missing 3, that's like $42 plus tax. So just check your locker. Maybe you accidentally took one. And don't worry, I've been blaming everyone all day. Every class I've been yelling the same. We've been trying to write 3 as many ways as we can back there, so. I don't know what the one before the Roman numeral is. Bryce wrote that one. What's the one above that one? Pig Latin. Oh, goodness gracious. Pig Latin. Okay, so what we have to work on are the asymptotes. So normally tangent by itself, just tangent of x, has asymptotes at pi halves and negative pi halves. Like, they're always going to be asymptotes as long as the period doesn't change. But if the period changes, this is how you can find 2 consecutive asymptotes. And this is what I'll be doing every time we graph this, is I'll start with my asymptotes. Because if I can find my asymptotes, then I know that graph. So you're going to set bx minus c. Notice that's like tangent of bx minus c. So whatever is here with tangent, set equal to the normal 2 asymptotes, which is pi halves and negative pi halves. And every single time, halfway in between your asymptotes, or the midpoint, will always be at 0, which is super great. And then it just makes those S shapes. Bless you. I was just trying to see what was next. I think maybe cotangent's next, or maybe a graph of tangent. I don't know. Anybody done writing that? Someone should have printed those notes out for you, huh? No, mine weren't. Mine handwritten. Like, the ones I printed on aren't written on anyway. Oh, look, I can look what's next. That's it. This is all the writing you have. The rest are graphs. You got a lot of graphing to do this chapter. just like sine and cosine, you've got to know what the normal graph looks like. You've got to know how to find the asymptotes. And then once you do that, it becomes a lot easier to graph. You're not just hopefully randomly picking numbers. So when it says graph y equals tangent of x over 2, step 1 to me is let's find two asymptotes. Because once you find two asymptotes and you know the distance between them, they're going to be equally spaced. And how do we find two asymptotes? It's what you just wrote down. Every time to find two asymptotes, you're going to take whatever's here, and you're going to set it equal to where the normal two consecutive asymptotes are, which are at negative pi halves and pi halves. And that's the part that you got to know by the time we take a test. How do I find two asymptotes of tangent? That's how you find it. And then you're just going to do the algebra. And what would you do on this? If you want to solve for x, what would you do? Multiply by 2. So we would get x equals negative pi. Yes? And on this side, if I multiply by 2, I would get x equals pi. Which means my asymptotes have changed because my period has changed. We can find the period if you want, like just to check and make sure that everything's lining up here. But if you find your two asymptotes, like the distance between them will always be your period. But just to throw it in on this one, the period is pi over b. What's b in this problem? 1/2. So pi over 1/2 is really like saying 2 pi. Is that the distance from negative pi to pi? Is that a distance of 2 pi? Yes, that means that that's all lined up. It seems like we did our math right. Your directions are always going to say graph two periods. So let's think about if I made this negative pi and I made over here pi, that's a distance of 2 pi. Where would my next asymptote be? Because they have to be the same distance apart. What would be my next line over here that would be an asymptote? 3 pi. It's not a trick. If the period's 2 pi, if I added 2 pi to pi, my next asymptote would be at 3 pi. So that kind of helps you to find your next asymptote using your period. So I could go over here. I'm going to graph a negative one too, just so that you can see it. And that's where I start. I start with my asymptotes. Like I was using a different color here, but that's okay. So I'm going to go through and I'm going to say there's an asymptote here. There's an asymptote here. There's an asymptote here. There's an asymptote here. I'm graphing 3 periods of this. How do I know? Because I've got 3 spaces in between my asymptotes. And then if you're not sure what's going to happen, pick a point and make sure, but every single time, what's going to happen halfway between your asymptotes? It's always going to be 0. And you can check. If you plug in 0, the tangent of 0 is 0. If you plugged in halfway between pi and 3 pi, you'd be at 2 pi. Plug that in. 2 pi over 2 is pi. The tangent of pi is 0. It's always. And then the big thing is you got to know which way the little S shape goes. And if you're not sure, just pick one point. If you picked halfway between 0 and pi, what would be that angle right there that we'd be picking? Pi halves. When you plug pi halves into that, what's the angle becoming? Pi halves divided by 2 is really pi force. And what is the tangent of pi force? 1. Which means if you're not sure which way the little S shape is going, if you just check that one value and you know the shape, you're like, oh yeah, I forgot. That side goes up, which means if I go halfway back here, this side goes down, which means I'm just having my little S shapes. What's changed on this problem? The x-axis. On the last problem, this was at pi halves, or the period changed, the asymptotes changed.
Will it always make like that way unless it's like negative?
Right, if this was a negative in front of it, do you agree that it's going to flip, and then this side's going to go that way, and that side's going to go that way?
Yeah, so if we just know the general idea, we don't have to pick it.
Oh, notice I have no XY chart, right? I never have an XY chart on tangent because I always know halfway I go up, halfway I go down.
And like, was the other, like, both sides, like, all three of them, they would
It
all
just repeats itself. Yes, yes. So if one of them is negative, they're all, like, these are always going to be the exact same graph. So if this one flips over, they're all going to flip over. And we talked about this yesterday, and hopefully we'll get to one of these today too. Fail. It's nice that I can just do this, right? Oh, the good news is that I caught it, right? If there was a number in front of this, what's that going to change to your graph? Yeah, instead of going up to 1 and down to -1, whatever number's in front, it would just go up to that number and down to that number. So again, you can plug into numbers and check, but the idea is you should know what shape it is, and you don't have to do that every time, as long as you find your asymptotes. Okay? What about cotangent? What's it going to look like? So tangent is sine over cosine, which makes cotangent which means, are we going to have asymptotes on cotangent also? But they're going to be in different spots, right? Because on tangent, your asymptotes are when cosine equals 0, because cosine's in the bottom. On cotangent, our asymptotes, or what x is not allowed to be, is going to be when sine of x equals 0, because we can't have 0 in the bottom. So where does sine equal 0? Sine is y, right? 0, pi, 2 pi, 3 pi. Right? Everywhere on the x-axis of the unit circle, y is equal to 0, so you'd have 0 on the bottom. So just like we wrote out yesterday, we could write this out real fancy and just say at any multiple of pi, so we say that that's at pi times n, where n is an integer. Which means the big thing to me, how do you know whether you're looking at a tangent graph or a cotangent graph, as long as there's nothing crazy going on with the period change, is you have to look at the asymptotes. Because the asymptotes on here are going to be different than the asymptote on tangent. Because on tangent, we had asymptotes at pi halves, at 3 pi halves, and on cotangent, we're going to have asymptotes at 0, and at pi, and at 2 pi, and at negative pi, and at negative 2 pi. So the y-axis is going to be an asymptote. At pi is going to be an asymptote. At 2 pi, at negative pi, at negative 2 pi. And then let's do the same thing that we did for tangent. Let's pick halfway in between. What would halfway in between 0 and pi be? What is the cotangent of pi halves? Because it's x over y, 0 over 1. So again, notice halfway in between your asymptotes is 0. And guess what? That's always going to be true. Just like on tangent, the asymptotes are in different spots. But halfway in between is always going to be 0. Now, what would be halfway between 0 and pi halves? What would be this value right here? The tangent of pi force is 1. So what's the cotangent of pi force? Still 1. But notice what happens is my asymptotes have moved. Now this side is going to go up to 1. Now this would be 3 pi fourths. And what's the tangent and cotangent over there in quadrant 2 at 3 pi fourths? Yeah, it's negative 1, which means this side goes down. So how does cotangent look different than tangent besides the fact that their asymptotes are different? Tangent goes like this, cotangent goes like this. Really easy to mix these up because if the period changes, the asymptotes change as well. But you got to pay attention to where your asymptotes are, where your asymptotes should be, and which way they should go.
So cotangent would be the same as the
The shape of it, but the asymptotes are still different, right? Like think about if you just had negative tangent, you're right. It would be shaped like this, but the asymptotes would be in a different spot. So part of your homework today is just matching up graphs, like which one of these is negative cotangent, which one of these is maybe negative tangent, like they throw those negatives in there to try to confuse you. Look at your asymptotes, because it's really easy to mix these up. I always say, especially like on a test, pick one point and make sure you're going the right direction. Like pick pi fourths and make sure you know which way you're going. But then just like tangent, it's going to repeat itself between every asymptote. So once you get one set done, it just repeats itself over and over again. So when it says to make 2 periods, you only got to make 2 of those. Like I just grabbed 4 periods because I just always go from 2 pi to negative 2 pi.
Can you come look at this really quick just to tell me what I did wrong so I can't start it? Did I?
This was, we changed our period on this one, right? This is original tangent. This is what I'm talking about. Original tangent had asymptotes at pi halves and negative pi halves. But you're right. The graph that we just did on the one before this, our asymptotes were at pi and negative pi, right? But that's because the period changed. So just like sine and cosine, could you do a period change and throw a negative in there and you could make tangent look like cotangent or cotangent look like tangent? Follow me on that? If you throw a negative in and flip it over, change the period enough, you shift it enough, you could line it up. So, but you got to remember the original one is where cosine equals 0, okay? So maybe let's just graph another one with some crazy stuff in there. Let's see what happens. Do I have this written out? There we go. Let's write this out on here for a minute. To find your 2 asymptotes of cotangent, you're going to do bx minus c equals 0 and bx minus c equals pi. Because your asymptotes on normal cotangent are at 0 and pi. So if there's some crazy period change, that's how you can find 2 asymptotes, all right? So that's the big thing that you got to keep straight. I don't memorize this. Like in my head, when I just wrote this down in my head, I thought cotangent has sine on the bottom, where does sine equal 0, and that's how I knew to put 0 and pi there, okay? That's the big thing, finding your asymptotes. The period on this is the same as tangent. It's pi over b. Your period is the distance between the asymptotes. So just like sine and cosine have very similar things, tangent and cotangent have very similar things. The 2 graphs that we're going to do tomorrow, our secant and cosecant, are very similar in their asymptotes and their period. But you got to be able to do these. So let's look at this one. So again, I'm going back to tangent. I think I have one more cotangent also. And then the ones in your book that you have to graph tonight have these directions. Find 2 consecutive asymptotes or vertical asymptotes, and then graph at least 2 periods. You're welcome to graph more, but on a test, on a quiz, on a homework quiz, if it says graph 2 periods and you don't graph 2 full periods, then I will mark off for it. So now we're back to tangent. So step 1, let's find our asymptotes. So tangent has cosine in the bottom, and if you go back to what we wrote out, to find your asymptotes, you're going to set 2x equal to negative pi halves and 2x equal to pi halves. And then you got to be able to do that math, right? With or without a calculator. I will give you a calculator on this, but you still got to be able to do this. If you divide by 2, isn't that the same as multiplying by 1/2? I feel like that helps people a little bit more than dividing by 2. Which means you're actually going to get a smaller period there. That's negative pi fourths. So if you divide by 2 here, that's just going to be positive pi fourths. What that's giving us are 2 asymptotes in a row, a -1 and a +1. That distance has to be the same throughout that problem. You really only need to graph 3 asymptotes. That'll give you 2 periods. If you want to graph more than that, you can. But that's where you have to start on this. So if I was doing this, I would go ahead and label this negative pi fourths. I would label this pi fourths. And then my graphs, just like sine and cosine, they tend to look the same all the way through. What changes is how I label my axis. I'm going to maybe move this down a minute so I can go further. Where would my next asymptote be? And that's where you have to kind of think about distance here. How far am I going if I go from negative pi fourths to pi fourths? Pi halves. So you need to go pi halves more to get to this angle, which you can just do pi fourths plus pi halves, or maybe you could think about this would be like negative pi fourths to 0 to pi fourths. In the middle here would be 2 pi fourths, so this would be 3 pi fourths. You don't get that from there, but you have to get that next asymptote, because that's what I'm looking for on your graph, is are you labeling it correctly? They have to be the same distance. Once you have that, draw on your asymptotes. I'm going to have an asymptote here. I'm going to have an asymptote here. I'm going to have an asymptote here. And what should happen halfway in between? Zero. No matter what's on there, because I'm not going to give you a phase shift, it's at 0, right? Even if there's a negative in front, even if there's a 2 in there, even if there's a number in front, when you multiply something times 0, you're still going to get 0. And then this is where I say, because it's easy to mix up tangent and cotangent, not a bad idea to check one number. You can write it down or just do it in your head, but check one number and say, okay, what would I be picking if I pick halfway between 0 and pi fourths? What would I be picking here? Pi eighths. So just check to make sure what's happening for that first one, because you know it's going to be an S shape. It's just knowing which way it goes. If you plug in pi eighths here, do you agree that 2 times pi eighths gives me that favorite angle of pi fourths? And what is the tangent of pi fourths? 1, which is why normally tangent goes up 1 on this side and down on this side, and it goes like that, right? But that negative is making me get a negative 1 because it's flipping it around. So that's why I say you could pick one number just to check to see what's happening. The negative means it's actually flipping down, which means it kind of looks like cotangent. But how do I know it's tangent? Because the asymptotes tell me. Cotangent's going to have an asymptote at 0 every time because we're not doing phase shifts. Cotangent's never going to go through 0. And then once you get that first one, it's just repeating the pattern here. And that's really all you have to graph, because you only have to graph 2 periods. Graph more if you want. How do you feel about that? Overjoyed? Let's do another one. Told you we had a lot to do here. Couple things to notice right away. There's a 3 in front of that. What's that mean when I make my little S shape? it's going to stretch. So instead of going like to 1 and -1, I know right away when I see that, oh, it's going to go up to 3 and down to -3. So it's going to stretch that S shape out. And then I have to find my asymptotes. Do not start making a graph until you find your asymptotes. And this is the part that you have in your notes right now, so it's easy. But on a test or a quiz, you've got to know, what do I set that equal to get my 2 consecutive asymptotes? And I always go back to thinking about cotangent is cosine over sine. So I set it equal to when sine equals 0. And that's at 0. And that's at pi. It's either going to be 0 pi or negative pi halves and pi halves. And then you just solve it. And this is what I'm saying about it's always going to have one at 0 that we graph, because I'm never going to give you one to graph with a phase shift. So no matter what's in front of this, when you divide 0 by that number, you're always going to get one at 0. And then this one's what's going to change. This is going to change to 0 and pi fourths. Which again, I'm only going to graph 2 periods, which is why I've made a small little graph over here. So I'm going to have an asymptote at 0. I'm going to have an asymptote at pi fourths. Courtney.
Does that mean you also have an asymptote for negative pi fourths? So they'll be equal distance. So then I could have like worked out like all of that right there.
Yeah. So if you wanted to graph a -1, you need to go the same distance. So yeah, if you wanted to just go to negative pi fourths, that's going to be your 2 asymptotes at negative pi fourths, 0, and pi fourths. If I was going forward, where would that next asymptote be? Right, because you have to go, this is pi fourths, so this would be like 2 pi fourths, which is pi halves. But yeah, that's a good idea, just to go negative. That works great. Draw in those asymptotes. I'll tell you the number 1 mistake that people make on cotangent is they draw in this asymptote, and they draw in this asymptote, and they forget that 0 was an asymptote also, and then they're trying to make a graph that goes through there. So make sure you label the asymptotes that you have. I'm going extra here. You don't have to make all those, but I'm actually graphing 3 periods here. Make sure you label this, right? I know it goes up to 3. If you only make 1 line and you label it 3, that's okay. But label things. If you don't label your x and y axis, I cannot give you credit for just drawing in a random S shape there. So there's no negative here, but again, we can still check 1 if you want. Halfway in between should always be 0. And I always think about going back is going to give me the positive 1, because that's going to give me that pi fourths. Like, what would that even be? The halfway in between would be pi eighths. So halfway in between that would be pi 16ths. Is that right? Which would work. 4 times pi 16ths is pi fourths, which gives me 1, but I'm stretching it all the way up there to 3. Are you with me on how I'm not making XY chart every time? You can. You're always willing to. Like, you're welcome to. But I don't, hopefully you don't have to. Like, because halfway in between here is going to be -3. And so what I'm looking for is that you're taking that and you're stretching it by a factor of 3. And then you just repeat the pattern. And as long as you make 2 of these, that's 2 periods, and you've completed the requirement of this problem. Don't do this. Don't make that big of a graph and then only draw 2 of them, because to me that is an incomplete graph. If you're only going to draw 2 of them, do not label this over here, like, because then I'm going to say, well, why didn't you fill in the rest of your graph? Because if it's there, then you really should fill it in. And that'll be my problem. So there's a few, maybe like 4 that you're graphing tonight. The rest of the ones with graphing are like matching, or like saying which one of these is the right graph, and matching those up. And it's just tangent and cotangent, so it's trying to mix those up. The other thing that's on your homework is going back to 4.4 day 1. That homework quiz that we took last week, and I asked like what was the muddiest point for you. The most common answer was 4.4 day 1. I'm still struggling on it. And that's going to just keep coming up in this chapter. They just throw it in at the end. And so that's why I spent a whole day on it to begin with, and now we're just going to keep going back to it. So let's do a couple more examples, and then I'll stop. Like just these 2, and I'll stop, I promise. Even, you'll be okay. I can give you some more paper if you need to. We're boosting the economy by writing our own notes. use like so much paper in math class. Like, this is a class I always use the most paper in. Math. I gotta write my notes and I gotta do my homework. There's a question similar to this on the chapter 4 test, the no calculator part. The only difference is instead of giving you an interval, they gave you like, if tangent is this and sine is negative, and it kind of told you what quadrant to be in. Same idea. On your homework today, it's broken up into 2 directions. One set of directions say you should be able to do this without a calculator, and that's the kind of stuff that you're going to expect to see on this test without a calculator. It's stuff like this. Like, you should be able to do this without a calculator because this is from our unit circle or our special triangles. And then there's another part of your homework that says use a calculator, and that's like the worksheet where you had to use a calculator sometimes. So we're going to do one with a calculator, or without, and with the calculator. Super important, this part right here. Where am I if I am between 0 and pi? Quadrant 1 or quadrant 2? I want to know what angle has a tangent value of the square root of 3. So I think we can eliminate some options here. Where's tangent positive out of quadrant 1 and quadrant 2? Is it positive in both of those? It's only positive in quadrant 1, which means if I know I'm doing this without a calculator, it's got to be one of those special angles. It's got to be pi 6th, pi 4th, or pi 3rd. I mean, I guess it could be 0 or pi halves, but it's not because I know that's not the square root of 3. Right? How could it be pi 4th? It can't be pi 4th because we know pi 4th is square root 2 over 2 square root 2 over 2. Yes? Which means if you have any clue what this question is asking you, you should be able to figure out that you're in quadrant 1 and it's either got to be pi 6th or pi 3rd. And even if you just got it down to that, you're down to 50-50 guess at this point. Yes? Like, use what you know about the quadrants and about where square root of 3. Now, you guys are unit circle people. I'm a triangle person. Like, for me, at this point, I would draw in this, and I would label my triangle sides. I'm not going to do that. I don't want to confuse you. What I am going to do is label my points here. And I think that's going to be square root of 3 over 2, 1/2. And that's 1/2 square root of 3 over 2. Tangent is what ratio? Y over x. Which one of those angles is going to give me square root of 3 over 1 as my tangent? Remember that when you're doing this, this was Philip's shortcut that I've never done in my life, but it works every time because every time your denominators will cancel out. If you're doing this, y over x, you can just take the top numbers over each other because the 2's are always going to flip up and cancel out. So like when you're doing tangent of pi 6, it's y over x, so it's 1 over the square root of 3. When you're doing tangent of pi 3rd, it's square root of 3 over 1 because the 2's always cancel. Yes? So let's answer that question again. Which one of these angles has a tangent of square root of 3 on top? Pi 6 or pi 3rds? Pi 3rds. Which means if you know your unit circle or you have your unit circle handy, there's not a lot of work to show with that. It's just knowing what it's asking. I'm looking for an angle in quadrant 1 or 2 that has that tangent. How is that different than what we did 4 day 1? That's not asking me to go all the way around the circle. And on your homework today, sometimes they give you like 2 quadrants, sometimes they give you a like specific quadrant, sometimes they give you the whole circle where you have to give 2 answers. So it's really important that you pay attention to this part. Okay? But use your unit circle. You should not be using your calculator, and the directions say that. As opposed to questions like this. Use the calculator. And again, there are very similar questions to this on 4 day 1. Step 1 is look at this. It's telling you to be in radian mode. It also tells me if I'm going all the way around the circle, how many answers should I have? I'm always going to have 2 answers because every trig function is positive twice and negative twice. So that's the other thing it tells me. And remember that cotangent is not on our calculator, so we have to think about if cotangent is 1.2, then tangent is 1 over 1.2. And what do we type in our calculators to find out what angle that is? The inverse tangent of 1 over 1.2 in radian mode. So in radian mode, you should type that in your calculator, and it should give you an answer. Inverse tangent of 1 over 1.2 is, that's telling me that at about 0.69 radians, the tangent, or the cotangent, is 1.2.
And when they went on the test, it was like that. Where you have to the n switch for 80, so like I did the inverse out of like 1 over. Wasn't like,
Yes, but it wasn't,
but it wasn't like this.
right, yes.
Just take the test for your break.
Everybody with me on that? You get that on your calculator? Now the next part of this is the brain work. With or without a calculator, if they ask you to go from 0 to 2 pi, there's 2 answers. Without a calculator, you can just go around your unit circle and see which angle has that value. But on the ones that give you weird angles, you have to be able to think about what quadrants this is true in, maybe think about reference angles. 0.69, do you agree that that's up somewhere in quadrant 1? That's a small angle, so I'm just going to say that's 0.69. And that's true. Is tangent and cotangent positive in quadrant 1? So that makes sense. My calculator gave me an answer in quadrant 1. What other quadrant is tangent and cotangent positive in? What could I do to get from this angle to that angle? Which means to find my other answer, I could take 0.69 plus pi, and my calculator is never going to give me that answer of 3.83. But you got to give me that answer. And we're going to do this on today's homework. There's going to be some on tomorrow's homework with secant and cosecant. This stuff's not going away, and I'm hoping that it's going to kind of maybe help clear up some of the confusion that we had on 4.4 day 1. Okay, so you're doing all of 4.5 day 1 homework today. Like the last 5 or 6 problems are like this, but the rest of it is over the graphing stuff. So this is 4.5 day 1, and you're doing all of it. Once you get this written down, if you'll open your book to that page and look at the first 2 problems, because everyone always gets confused by it, but it's really just a matching problem that people always get confused, so I just want to help you out. Page 401, 402. I believe those 4 are the ones you're graphing. Yeah. Those are the only ones you're graphing. The rest of them are like matching, and starting at 31 are the solving ones. So there's not a huge amount of graphing. But just so you know, if you'll get that written down and look at number 2 and number 4, people get really confused by it. But there's 2 different graphs graphed on the same graph. There's a blue one and a red one. And they just give you 2 equations. So like, I'm not going to actually do the answer to this. But like it says, one of these is 0.5 tangent x, and one of them is 5 tangent x. You see that on number 2? They just want you to think about what is that number in front to. So for 5 tangent x, is that going to be the really flattened out one, or is that going to be the really stretched out one? For this one, right? Like if you had a 5, sorry. Okay, sorry. Sorry, I was going with the 5 one. But you're right. That one's going to be the flattened one. That one's going to be the stretched one, because instead of going over 1 up 1, you're going to go over 1 up 5. And they really, some people in second hour call them blue and red, and I'm okay with that, but they really are labeled y1, y2. They just want you to say, like, this equals y1, or this equals y2, whichever one it is. That's all there is to do on 2 and 4, but people always get freaked out, and they're like, I can't even do the first problem. So I was trying to just help you. You're just matching. And then when you get to 13 and 14, it's just multiple choice. You're matching with the 4 graphs above it. But these 4 in the middle, those are the graphing ones. Graph 2 periods, at least 2 periods on those 4 problems. All right? We're going to do secant and cosecant tomorrow. I will go through a few questions over this. But if you have none of this done, or you come in and you feel like you don't know how to do any of this, you need to come in early in the morning. Like, I will not be spending 30 minutes of this class tomorrow going over these questions. Like, we are doing secant and cosecant tomorrow. I'm getting you back on track. So that Friday we can be all caught up. We're skipping this little graphing calculator thing, and I'm going to do the second hour tomorrow, and you guys don't get to do graphing calculator. That's not on your test. Just extra bonus. Not bonus like extra. Do your homework. That's what it is. I want to retake it. Oh, we have first part. I just in the morning, but I don't think they're going to be able to take that. I thought my college actually has to be logged into the college service. Do you have study hall?
Or you could just call it that.
We'll figure it out. So, not in the morning. Yeah, I'm not sure. In the morning, and we'll see. If you know it, you should be able to do it, but yeah. Maybe let's just try 7:35. Whether it's for the best or right? Then I've done you.
I gotta
So come in the morning and we will see. Which part of the test are you taking? No calculator. No. Okay, I don't remember. I forgot. I have about 1 million retests to grade along with 1 million test questions. Super exciting.
You're not gonna have to scrape it today.
And I have my formal evaluation and Mr. Beckett tomorrow, and I haven't done that yet, and my room's a mess, and yeah, these are not going to get great. I'll be right back. Circle.
Jenny, copy to the guidance office. Jenny, copy to the guidance office, please. Thank you.
Test. Hold on. I don't think we start on it and I'll say.
City Foster's office, please. I need that call.